Good morning. My name is Bhairavi Shankar and I'm here at the 2017 Canadian Science Policy Conference. And joining me today is Dr. Donald Stuss. He is the founding director of Baycrest's Rotman Research Institute and the president and scientific director of the Ontario Brain Institute. Welcome, Dr. Stuss.
Thank you. The former president and scientific director. I just stepped down.
All right. So tell us about your work at the Ontario Brain Institute and what is important and what makes it unique.
So the Ontario Brain Institute was funded by the province of Ontario as a means to address the really important issues on brain dysfunction, the important diseases such as Alzheimer's, etc., and realizing the huge societal impact, not just financial, but social. And the idea was, could we integrate the people in Ontario to work together in a way to tackle these major problems, I think, in society, not just in Ontario, but worldwide. And so the Ontario Brain Institute, I think, is unique because what we were able to do is to get people to agree to a standardized approach. And we embedded research into care. There's basic science going on, but it's all within the patient framework. We have industry and commercialization that are involved. And the goal is to transform care through science. In doing so, the people have agreed across the province, if they're involved, to do the same assessment, which would be at a research quality. So by the mere fact of doing that, the quality of care itself is already improved without even the science going on, because it's done at a research quality. All the data goes into a database of standardized data so that eventually can be shared, both within Ontario but also nationally and internationally. And some of the major disorders that are being attacked are dementia, different kinds, autism, depression, the epilepsy, and cerebral palsy. And the idea is also to look across diseases. So it's unique in that way.
Right. And so in this process, you must be working with several members from different backgrounds and fields, even within the medical profession.
It's truly trans and cross-disciplinary. So it goes from genetics to all the different kind of omics, proteomics, and genomics, to neurology, psychology, occupational therapy, and also engineering. So all of this is integrated, plus industries involved. So it's truly transdisciplinary, and where people come together to work together and share ideas. And I think that's one of the major advantages is by coming together to share, ideas can leap forward.
So in that context, what are some of the approaches that work in that scientific inquiry and knowledge expansion process?
So I'll give you a couple of examples, because they are examples that kind of dumbfounded me.
Okay.
And one example is, if you start to gather a lot of data together to realize that the outcome in every individual person, that there are many factors that go together to actually say that if you have a disorder, if I have a disorder, why do you get that one and I get that one, even with the same genetic background? So there's one example of identical twins. So identical twins are identical, right?
Yes.
One has a disease, the other does not, of a degenerative disease.
Right.
It makes no sense. Other than, this is what excites me, the no sense means what's going on, so you have a research question.
Right.
The research question then changes the way you're going to do the diagnosis, which is going to change the treatment. But it happens at all levels. You start to see, even across diseases, that there are comparabilities. So it's between autism and ALS, Lou Gehrig's disease.
Right.
So what are the comparisons? They may be using the same drug. It makes no sense for them to do that. So you have a research question. So what it does is provide the ability to actually be transformative in the way you ask questions.
Given that multidisciplinary approach and participation, what, in your opinions, are successful ways of engaging that scientific inquiry and collaboration?
So it enables you to actually look at every person in a unique way because you have data from genetics to behavior. And you start to understand by this approach that the expression of a disease is no longer as simple as we thought. We used to think that there would be Alzheimer's, and we now realized there's multiple types of Alzheimer's disease. The groups that study depression say there's no depression, there are depressions. And then when you start to think of that, you then say, well, that means if this pharmacological treatment doesn't work in that patient group, but it works in this group and not this group, what does this group have that's different than that group? And then you ask another question, and then you start to see a treatment effect and then study different treatments. But you then start to connect the mechanisms, the causes that may be multiple levels. It could be environmental, it could be genetic, it could be at the molecular level, to start to say, well, you or I will have a certain expression of a disease. Totally transforms our approach to diagnosis and eventually care.
So you will be participating on a panel later on today. Would you mind talking a bit about what that panel is about, who the members are, and what you hope to get out of that discussion?
So there are several people who are going. Dr. Mark Poznansky, who's head of the Ontario Genomics Institute, is the chair of it. There's myself. I'm not going to remember the names of them all, but they're from different disciplines. Because actually people I haven't met, but they're brought together. That there are people that are working from a outcomes end, or people working from a computer end, that are going together. And the idea would be, how do we look at science differently to handle the big societal challenges of today? Because we have to do something. If you think of the aging population, the disorders that are increasing, we're staying alive longer. How many disorders become involved? And then what we call the comorbidities, that will end up having more than one disease, or how pain affects the expression of the disease, and how you use data. The idea of the panel is made up of different groups, so that we can actually to discuss the idea of how we can use our talents to actually address science differently.
And would you, if I'm understanding it right, would you hope for there to be a maybe standardized approach to that, addressing the societal events?
So the interesting thing is, it depends on what level you're asking that question. So you need something standardized. In other words, if I'm going to test you and test me, we have to do it the same way, otherwise we're talking apples and oranges, correct? Which means you got to get people in the province or beyond the world to agree.
Yes.
That doesn't always happen. There are different levels of studying disease. So for example, in autism, there are 28 mouse models of autism. They're not all the same disease.
Interesting.
So right, exactly. But when they're published as a mouse model of, they're not published as this specific mouse model. So there has to be a standardization across, or a subgrouping. But from a research perspective, what the gathering of the data in the standardized way hopefully brings a non-standardized approach, where people are going to think, we got to think outside the box. We got to think of this differently. What's another way of analyzing the data? So I'll give you an example. In our dementia group, the neurodegeneration group, they're all getting the same exam, but they're now studying, they're not just studying Alzheimer's, they're studying different types of dementias. So Alzheimer's, Parkinson's, ALS, frontal temporal dementia. But they're studying them the same way. Now, some people argue does Parkinson's cause dementia? The answer is we don't know, but there is it's a degenerative disease, we know that. But if you give them all the same exam, including the same cognitive exam that you would give to the Alzheimer patient, in some of the Parkinson patients you pick up problems.
Right.
But supposing you give the Alzheimer patients a motor exam, like you give to a Parkinson patient, you actually start to see in some Alzheimer patients motor problems such as balance. So you have this idea of then you're almost forced to think outside the box because looking at the data in that way provides you these what's going on, the surprise. So in a sense that's not standardized. You want people to be creative from the very basic science to the behavioral science.
Right. And given that we're at a science and policy conference, what is your thoughts on how that analysis might lead towards maybe a policy change?
I strongly believe that there's a way to approach science. I think fragmented science is good, but integrating it together is better. So basic science, people doing molecular genetics, you need to have that. It's the source of knowledge. But if I can integrate that within a clinical framework, that what I get then is that, first of all, closer linkage, but then the basic people asking questions. If I just say, I've just shown you that these Alzheimer patients aren't all the same, what are you going to do with your genetic work? It changes the framework. So the idea is structuring the approach, allowing people, standardizing the approach, bringing the data together in a database. And Ontario has developed this, the Ontario Brain Institute has developed the database called Brain Code, where everything goes together. So you can start to ask questions that you never could before. And that's by bringing cross-disciplinary, multidisciplinary, interactive type work, including with industry. A lot of scientists have difficulty with industry. They're saying, well, you know, they have, and there have been problems in the past, they affect things. But if you bring industry up front, so they can't take anything that's not developed, but then they bring their expertise. And when it's developed, you got to move things to product. They're there. So it's a framework of bringing things together almost in a circular way rather than a linear way.
Right.
So I do believe there's, in that one could take this type of approach with virtually any problem.
Well, I thank you for your time here at the interview booth, and I wish you a great conference. And for people who are unable to attend here in person, how can they follow along with the work that you're doing and keep in touch?
Well, I would suggest that the best way would be to look at the website of the Ontario Brain Institute. There's a lot of information there. The person who's replaced me, Dr. Tom Mickelson, is doing a phenomenal job. But that website, and you would just look up Ontario Brain Institute, there's a lot of information, a lot of data that's provided on the different disorders, and I have to emphasize is that the patients and the families are also part of the entire protocol. So they have a say right up front and also pick up. So I would look at the Ontario Brain Institute website.
All right, well, thank you again.
Thank you.